So I've decided to put a short tutorial video together demonstrating how to turn the ATmega 328PU into a working but bare bones, minimal Arduino-alike on a breadboard. So we have a standalone Arduino communicating with the computer with a minimum of components, and those components are well, obviously this presumes that you've downloaded the latest version of the Arduino IDE. I'm using 1.6.2. As far as the hardware goes, we have an ATmega 328 microcontroller. I paid £6 for this from Cool Components, but you can get them much cheaper on eBay or Amazon. I'm also using from SparkFun FTDI board with a FT232RL USB to serial converter chip on board. This cost me £10, which kind of broke my heart, but again you can get them much cheaper if you do a search. So the remaining components are a 16 MHz crystal oscillator, 2 times 22 picofarad capacitors, a 0.1 microfarad or 100 nanofarad capacitor, and 2 10k ohm resistors, some breadboard and hookup wire. So that's one I made earlier. And you should take note that on the FTDI breakout board, the pins with the legend facing you are, from the right, DTR, RX, TX, 5 volt, CTS and ground. So we'll connect the components to the ATmega first of all. And the pins we're interested in are pins, they're numbered with the indentation to the left, a little dot down here, 1 through to 14, and then anti-clockwise 15 to 28. Pins we're interested in are 1, 2 and 3, which are reset the bootloader on the chip, RX and TX on 2 and 3. Then we're going to use 7, 8, 9 and 10. 7 is VCC, 8 is ground, 9 and 10 are the pins for the crystal oscillator. And then on the other side, pin 19, which corresponds with digital pin 13 of the Arduino IDE, and then pin 22, which is our ground source. So we take the crystal oscillator and connect that to pins 9 and 10, either leg or either way round. It's non-polarized. Then our 2 caps pull each of the leg to ground. 8 is ground. So we connect one leg on pin 9 of the oscillator to pin 8. That's 9 to 8 via a cap, and 10 to 8 via a cap. I think they filter out noise. I don't know exactly how critical those values are. I've seen circuits that use 18 picofarads, but I'm using 22. The next step is to pull the reset pin to 5 volts via one of the 10k resistors. Get him seated properly. So the reset pin 1 is going to pin 7 via 10k ohm resistor. What this does is it holds the reset pin high until it gets a data transmit ready ground signal, which then pulls that pin low briefly and allows new sketches to be uploaded. It's like a soft reset instead of using a push button. So that's it for pins 1, 7, 8 and 9. We'll leave 2 and 3 until we hook up the FTDI board. Around the other side we have 15, 16, 17, 18, 19 represents digital pin 13, and then 20, 21, 22 is our ground pin. So again, pull down resistor, circuit protection resistor, just to protect the diode, because we're going to connect an LED there, and I'm not convinced that he's seated properly. Yeah, that's it there. So we're going to connect an LED just for some visual feedback between pin 19 and pin 22 via a resistor. I'm just using a bit of silicone here just to diffuse the LED, make it nice and bright and visual. Now we need to hook up our FTDI board. So I'm using 6 male headers. Yep. Okay, so from the right we have DTR, RX, TX, 5 volts, CTS and ground. The first connection I'll make is ground. So remember that needs to go to either 8 or 22. It's more convenient to go to 80 to 22. So there's pin 22 connected to ground of the FTDI board. CTS, no idea. Don't know what he's for, but he's unused. Next along we have VCC 5 volts, and that is going to go to pin 7 for supply voltage. So 5 volts from the FTDI board to pin 7 after the resistor that we already have there, of course. Now we'll go from the chip. Pin 2 is RX, and that wants to go to TX, which is the third leg in from the right on the FTDI board. I'm orienting it this way. Then pin 3 on the microcontroller is TX, and he's going to go to RX. And lastly we have 100 nanofarad capacitor, again not polarized, so either way around will do, and that connects pin 1 on the right of the FTDI board to pin 1 on the microcontroller for the resistor. And that's our working standalone Arduino. All that remains, I'm going to do a section 2 video of this, which demonstrates the slightly more arduous task of getting your operating system to talk nicely with the FTDI board. I had nothing but trouble using the latest version, 2.12 I think, of the FTDI drivers on the Future Technologies website for this. So I had to do some finagling to get it to talk nicely, get with the Arduino IDE. So I'll hook up my LED. Come on. Pin 19, power of the LED. Pin 22 is ground. And we should have a single flash. Yep, single rapid flash. So I'll try and turn this around so that you can see. On the FTDI board there are RX and TX lights. What I'm going to do is just pull up another sketch in Arduino, put it onto the board using soft reset. So I go Tools, port. There's COM port 10. Familiar with that one. Processor Atmega 328. Board allegedly should be Arduino Uno, because these were sold as shipping with Arduino Uno bootloader pre-installed, but that doesn't work. So I've had to select Arduino 2.9 or 10.000 to get it to talk to that. So it's obviously a different bootloader, because it just wouldn't work if I selected Arduino Uno. So sketchbook, I have a double blink sketch here, just to verify that it's working. Compile it, and then when I hit upload, you'll see the red and green RX-TX lights on the board flashing very pleasantly for us. There we go, uploaded. There's my double blink.